This is an A2Pure video. We are on Unit 4. We're looking at integrations, and in particular in this one then we're going to look at volumes of revolution. So we can use integration to find the volume of a solid of revolution, i.e. the volume found by rotating the area between f of x, the x-axis, through 360 degrees. So this one's quite hard to see. Say you have this rectangle set up and you rotate it around through 360 degrees. We can find in the volume of that using a wee bit of integration, as you can see up here. So when rotating a rectangle obviously forms a cylinder. If you rotate then a right angle triangle, then that would form a cone. But other ones can be done as well. In our second example, it's just a regular quadratic curve, and as we rotate it around then you can kind of see the shape. So say we had our curve like this, and if you rotate that around you'll get that shape then as it rotates around, and we have kind of a way of working that out. So our formula for this, our volume between A and B, which in this case would be here and here, or sort of B and an A here, is pi y squared. So you do the f of x, you square that function, and then you multiply it by pi after that. So let's take a look at a couple of examples and see if we can get our answers in from there. So our first one is find the volume generated by rotating y equals 2x, 360 degrees about the x-axis when between x is 0 and x is 3. So we'll do a quick sketch here, a very quick sketch to be honest. Here is our y-axis, here's our x-axis, using whatever particular scale. There's the line then, y equals 2x, and we need to rotate that around. So we're going to get a cone in this particular case, that's between 0 and 3, our y-axis and our x-axis. So we use our formula here, our volume then is going to be pi, the integral between b and a of f of x squared with respect to x. So in this particular case, v is pi between 3 and 0. Our function is 2x, and that's all squared dx. V is pi, the integral again between 3 and 0, and that gives us 4x squared. Remember, we had to square the 2 and the x. So our volume is then going to be pi upon, add 1 to the power, divide by the new power, so 4x cubed over 3 between 3 and 0. 3 cubed is 27, times by 4 gives me 108, divided by 3 gives me 36. The other one's going to go to 0 obviously, so 36, take away 0, so our volume in this case is 36 pi, and I'm happy to leave it then like that. Let's take a look at example 2, a bit more to this one actually. The finite region bounded by the curve y equals 2x squared minus 3x, and the x-axis rotated through 360 degrees or 2 pi radians about the axis. Find the volume of revolution formed. So first of all, we need a wee sketch of the curve because we don't know where it's going to cross the axis and stuff like that. So let's get a bit of an idea of the shape, and we'll then take it from there. So we are going to sketch the curve. It cuts the x-axis at y equals 0. So we're going to have 2x squared minus 3x equal to 0, a reasonably straightforward one here. We're going to have, sorry, 0, I'm not sure why I've changed the 0 back there, it's just the way the notes are set out. 2x minus 3, so we have x is 0, and then x is 1.5, or 3 over 2. It cuts the y-axis when x is 0, and obviously it's a quadratic, we know x is 0, y is 0 in that particular case, but either way, y is 2 upon 0 squared minus 3 upon 0, it gives us 0. To find a turning point, which I suppose we need, but it gives us a bit of an idea, the turning point happens then for dy by dx is equal to 4x minus 3, putting that equal to 0 to find our turning point. Obviously get 4x minus 3, and it gives us an x coordinate then of 3/4. If you substitute 3/4 back into the original function, we'll not do that right now, but it gives you minus 1 1/8. So we have a bit of an idea then about what it is we're actually rotating around, so we can see where we're going with it. So here is our function. it crosses 0 and it crosses a 1.5. Our turning point is minus 1 1/8. It's down about here, and then that then is 0.75. So this is what we're rotating about 360 degrees, and by drawing the curve we know what's happening, and we know there are 2 points of integration where we're going to integrate in between. So let's look at our formula. Volume is pi integral b a f of x all squared dx. In our particular case, it's pi between 3 over 2 and 0 of 2x squared minus 3x all squared. So a wee bit to do here. Integral between 3 over 2 and 0. Multiplying that out, I think, gives us 4x squared minus 12. X cubed does not give me 4x squared, it gives me 4x to the power 4, obviously. Minus 12x cubed, and then plus 9x squared dx. Integrating that, 4x to the 5 over 5, take away 3x to the power 4, and plus 3x cubed. That's all between 3 over 2 and 0. Things get a wee bit messy here. If you sub in 3 over 2 then to each of those, you can get it to work out. My values here, I don't like to log off too much, but let's see if I can fit them in here. It ends up being 1.0125, which is sub in, and obviously subbing 0 in doesn't give anything. And that then is a fraction, is 1 1/80th, I think. I think we're on 81 over 80 pi, and then is our final answer. But it's this main bit up here, which is our new bit, and hopefully that'll make sense okay.